Okay, you guys, so here's my first attempt at this. We are going to use that equation that you just got introduced to in the last video to actually calculate the power on different appliances at home. So we're going to do a clock. I'm going to show you that here in a second where we find it. Every appliance is supposed to have information for us that's going to tell us the wattage, and it would also tell us the voltage that it would accept. And if we have those two things, we can figure out current from it. We can figure out a lot of things, but the biggest thing is we want to know current. So I'm going to use a clock. Okay, hold on. Gonna do this for a mixer. Hopefully not while it's on. And gonna do this. Hopefully I'm not making you dizzy for a crock pot. So 3 different appliances. We're gonna learn that new equation and figure out how do we actually find the current if they gave us the power rating, because that's what all of our appliances get, is they give us a power rating. So we're going to start with that clock, and I'll show you where you find that. Hold on. Okay, so we're going to do this first. Sorry for the clock. So this is the actual clock that we have here. Okay, let me see if I can zoom out a little bit. Guys, just be so that's as much as I can go, you guys. So be patient with me. But if I look on the upside down part of almost any appliance, it has to be stamped in here. And your eyes are younger than mine, thank goodness. Let me see if I can quit moving this around. And what I'm looking for is right here. So if you read this, it says AC, alternating current, 120 volts. So we are told the voltage. This hertz just tells you that it's moving at that speed. So that's not going to be information that we need at this moment. But here's my 5W. Remember, W is a watt, and that's our new unit when we think about power. So when we think about the power equation that we're about to do, that's going to help us. So again, I'm going to use this information right here that says 5 watts, and then I'm going to need this information right here that says 120 volts. So that's what I'm going to work with. Oop, I'm sorry. Okay, so the equation that we're going to use is P equals I times V. So P equals I times V. And remember, we just looked this up. P is going to be measured in watts. This is what the video just taught us. V is just like before. This is volts. And then I is current. So now I could find this. Remember, current is measured in amps. So if I think of that appliance, let me just help you again. Let's go back. This is measured in watts, and then volts and V. So that clock just told me that it has 5 watts and it needs to run off of 120 volts. Okay, so I can take that information and plug it into equations. So this is equal to my P value, and this right here is equal to my V value. So then again, if I have P equals I times V, I really have 5 equals I times 120. So this is an I, this is not number 1. So if we divide both sides by 120, we can find out how much current that particular machine uses. So don't ever tell me that you don't have a phone or a calculator, because we can use our phone, right, for a calculator. So what am I going to do here? Let's put this right here. I'm going to do 5 divided by 120, and then that tells me my amps. And we're just round. I'll tell you guys, maybe go a few digits past. Okay, so I'm going to, a lot of times I could probably stop at the hundredths place, so 0.04 amps. I'm about to get a new marker. All right, now we're going to move on to the handy dandy mixer. I have unplugged it, so I'm staying safe. Very thankful. This is going to be easier for my old lady eyes to read. So let me get this back in focus for you. All right, same information. I told you every appliance has to have it. It's a government mandate. So with this one, I am interested in this 120 volts that's right here. I'm going to use that. It tells me it's alternating current only. 60 hertz, that is the speed and the rate at which the electricity changes directions. So 60 times a second it changes directions is what hertz means there. And then 200 watts. We're going to assume that we're using max power. Okay, so that just means high speed. So at its max, at its highest speed, it is going to consume 200 watts of power. So the two important things here is the 120 volts and the 200 watts. If I have that, I can figure out the current again. So let's see how we do this. Same equation, P equals I times V. This is for our blender. We just found that on that blender, it tells us that, and this is how it's always going to be, we'll always be solving for current when we look at appliances. So the max power, highest speed, 200 watts. The voltage, it has to be plugged into a 120 volt outlet, and that's what our power company supplies to all of our outlets. And so then we, again, are looking for current. So 200 equals I times 120. Divide both sides by 120, and let's see what we end up with. Again, you can use the calculator on your phone to do this, no excuses. So 200 divided by 120, and I end up with, and let's just go to the hundredths place. So that appliance at full power is going to use 1.67 amps of current. All right. Okay, so here is our last appliance, the crock pot. Now I actually took out the pot and the lid, and I'm just looking at the heating element here. So what the pot and then the lid is housed in. And remember what I said, every appliance that's plugged in by law is required to tell us the voltage requirement. So what type of power or energy, voltage should be coming out of the outlet. And then also it's required to tell us the amount of power that's being used. So on this one, most of the time they're always on the bottom side somewhere. And it's no different here. Let me just turn the brightness down a little bit so that you can see it a little bit better. Okay, so sorry again, I know it's a little shaky, I apologize. But if we look here, I am interested in that 120 volt number. Trying to find something to point with. Oh, grab a pen. Sorry, you guys. It's a bad video right now. But that's 120 volt right here. At 60 hertz, I'm not as interested in for my calculation, but then there's a 240 watts. So again, 120 volts, which we're going to see a repetitive theme, and then 240 watts. That is what I am going to be using for this particular calculation. So with the crock pot, we have a power rating of 240 watts, and that would be the max power that it would be pulling. We have a current that we're going to be finding out, and the voltage that's coming from the outlet. Again, this is something that our power companies set for us so that the manufacturers of all these different appliances know what type of resistor to put in there for getting a certain amount of power or current to run through the appliance. So we want to know what kind of current runs through this. Last year I was making booyah, and I had probably 5 different Nescos that were going through my kitchen, and eventually my outlet tripped in the end because each individual Nesco was pulling a certain amount of current, and the entire circuit that all those outlets were connected to will only hold so much current. So I had to learn which particular outlet maybe was in a different circuit so that I could have all those NESCOs going. All right, so with this equation, same equation we've been using, P equals I times V. 240 is our p-value, I is what we're looking for, and then 120 is our voltage. So I'm going to divide both sides by 120, and 240 divided by 120, we can see right there without having to plug it in, hopefully, that that is 2 amps. So the answer to this question would be 2 amps being supplied. So for part of your homework, you're going to see this document posted, and I don't think that I printed this and gave it to you before you left. You have an option. You do not have to print this. I know that some of you don't have that as an ability. You can just write your answers on another sheet of paper, but I want you to go through it. There is some simple calculations here at first, same idea of what it is that we just went through. Then there's some that has you use both of our equations. So P equals I times V, and then also V equals I times R. And then down here at the bottom, you get to do kind of like what I did with 3 appliances. You get to also pick 3 different appliances and tell us what you find using both equations. So you're going to find power on the appliance. You're going to also be told voltage on the appliance. Remember, those 2 things are there. Then we are going to solve for current. And if we know current and we know voltage, then I can go back to that original equation that I was given, V equals I times R, to find resistance. So these are all things that you will do. I will be posting the answers, minus your appliances. I'll be posting the answers to all of these other problems also in this particular lesson. So you have something to check to.